Hello, space enthusiasts. Have you ever wondered how many of the space facts we've grown up with are actually true? The cosmos is a vast, intriguing place full of mysteries and marvels. But as it turns out, it's also a place that's ripe with misconceptions. From the visibility of the Great Wall of China from space to the dark side of the moon being permanently in shadow, it's time we put these myths under the microscope. And while we're at it, let's talk about whether sound really doesn't travel in space, or if black holes are the cosmic vacuum cleaners they're often portrayed to be. We'll also explore if time truly stands still when you're out there among the stars, and if the vacuum of space would make you explode. Today we're debunking some of the most popular space myths, so let's get started. Myth number 1. Can you really see the Great Wall of China from space? This claim has been floating around for centuries, and it's time we put it to rest. Though the Great Wall is an architectural marvel stretching over 13,000 miles, it's not visible from space with the naked eye. Why? Let's break it down. The primary reason is the wall's width. Despite its vast length, the Great Wall is only about 30 feet wide, too narrow to be seen from such a great distance. Furthermore, the materials used to build the wall are of a similar color to the natural terrain, causing it to blend in rather than stand out. So, from a satellite's perspective, the Great Wall is essentially camouflaged, making it even more difficult to spot. Now you might be wondering about astronauts and their high-tech equipment. Well, even they have confirmed the difficulty of spotting the Great Wall from space. The wall's narrowness and its blending with the natural terrain make it a challenge to discern, even with the aid of powerful lenses and cameras. So, despite its grandeur, the Great Wall remains a terrestrial marvel. It stands as a testament to human capability and endurance, but it doesn't quite make its mark in the cosmos. The myth of seeing it from space is just that, a myth. Moving on to myth number 2, is the dark side of the moon always dark? This is a common misconception that many of us have, but let's dive into the facts. The moon, like our Earth, is a celestial body that spins on its axis. But here's where things get a bit special. The moon is tidally locked to Earth. This means it rotates on its axis at the exact same rate as it orbits our planet. Sounds a bit confusing, right? Let's break it down. When we gaze at the moon, we're always looking at the same face, the near side. This happens because the moon takes the same amount of time to spin once on its axis as it does to complete one orbit around Earth. But what about the far side, often referred to as the dark side? Well, it's not always dark. In fact, it gets its fair share of sunlight. When the moon is between the Earth and the sun during a new moon phase, the far side is fully illuminated by the sun. So, while we on Earth can't see it, the so-called dark side of the moon experiences a cycle of daylight and darkness, just like the near side does. This cycle is what makes up a lunar day, which lasts about 29.5 Earth days. So, the dark side is a bit of a misnomer, isn't it? Now, let's tackle myth number 3. Is space really silent? You may envision space as a vast silent void, and in many ways you're not wrong. But here's where it gets interesting. Sound, as we know it, requires a medium to travel through, like air, water, or a solid object. In space, the lack of air makes it impossible for sound waves to travel like they do on Earth. But wait, does this mean space is utterly silent? Not exactly. Even though space is a vacuum, it's not a perfect one. There are still sparse particles and cosmic dust floating around. These particles can carry vibrations, which are a form of sound. However, these aren't sounds that we could hear with our human ears. They're more akin to electromagnetic waves. These waves can be detected and translated into sounds that we can hear. NASA has actually done this, converting the vibrations from space into audible sounds. So, if you were hanging out in space with the right kind of equipment, you could technically hear these sounds. However, it's important to note that these sounds are not like anything we'd recognize on Earth. They're more like eerie hums and whistles than anything else. So, while you won't hear a symphony playing in the cosmos, space isn't as quiet as we might think. Hence, while space isn't exactly filled with sounds as we know it, it's not completely silent either. On to myth number 4, are black holes really cosmic vacuum cleaners? The short answer is no. Let's delve into why. Black holes, these mysterious cosmic entities, are incredibly dense with an immense gravitational pull. But contrary to popular belief, they don't indiscriminately suck everything in their vicinity like a vacuum cleaner. To be sucked into a black hole, an object must venture past a boundary called the event horizon, a point of no return. But if you keep a safe distance, you can actually orbit a black hole, similar to how our planets orbit the Sun. In fact, our very own Milky Way galaxy has a supermassive black hole at its center, with stars safely orbiting it. In essence, a black hole is like a cosmic ballet, where objects can dance around it in orbits, unless they stumble too close. It's not an insatiable monster devouring everything in its path. It's this balancing act between gravity and orbital velocity that keeps things in check. So it's time we retire this misleading metaphor of black holes as cosmic vacuum cleaners. While they are indeed fascinating and have a strong gravitational pull, they don't go around the cosmos hoovering up everything in sight. They're more like cosmic dance floors, where objects can whirl around unless they trip and fall in. So, black holes aren't the cosmic vacuum cleaners they're often portrayed to be. Let's dive into myth number 5. Does time stand still in space? This tantalizing idea has been a staple of science fiction for decades, but what does science have to say? Well, thanks to Albert Einstein's theory of relativity, we know that time is relative and can be affected by gravity and velocity. This is known as time dilation. Imagine you're aboard a spacecraft traveling at near light speed. According to the theory of relativity, time would pass slower for you compared to someone stationary on Earth. So in essence, you would age slightly slower. But hold on, don't pack your bags for the fountain of youth just yet. In reality, the difference is incredibly minute for the speeds and gravitational differences we experience in space travel today. For example, after spending nearly a year aboard the International Space Station, astronaut Scott Kelly aged less than a fraction of a second slower than he would have on Earth. So yes, technically astronauts do age a bit slower in space due to the high-speed travel. But the effect is so negligible that it won't make a noticeable difference to human aging. In conclusion, space travel might affect time slightly, but it definitely won't halt aging. In the vast cosmic clock, whether you're on Earth or orbiting it, time marches on, and so does our journey into understanding the universe. Lastly, myth number 6. Will exposure to the vacuum of space make you explode? Hollywood might have you believe that the moment you're exposed to the vacuum of space, your body will instantaneously balloon out of proportion and explode. But let's set the record straight. This is purely dramatic fabrication. In reality, the lack of external pressure in the vacuum of space can have some pretty serious effects, but causing your body to explode is not one of them. Our skin is incredibly resilient and can withstand the pressure differential. So instead of exploding, your body would bloat up to about twice its size as the gas inside you expands. But this doesn't mean you'd have a comfortable time out there. Without the protection of a spacesuit, you'd suffer from a variety of unpleasant experiences like decompression sickness, also known as the bends. This occurs when dissolved gases in your body form bubbles and can cause joint pain and rashes. Also, the lack of oxygen would render you unconscious in about 15 seconds, and the extreme cold and radiation wouldn't be too friendly either. So while the vacuum of space is dangerous, it won't cause you to explode. It's always good to have a spacesuit handy though. Well, that was a cosmic journey, wasn't it? We've navigated through the vastness of space, debunking myths along the way. We unveiled that the Great Wall of China isn't visible from space to the naked eye, and the dark side of the moon isn't perpetually in shadow. We listened to the subtle sounds of space, which isn't a perfect vacuum, and learned that black holes aren't cosmic vacuum cleaners indiscriminately sucking everything in. We've discovered that although time is relative, astronauts age just like the rest of us, albeit slightly slower. And finally, we've understood that while the vacuum of space is dangerous and can have severe effects on the human body, it won't make you explode. So there you have it, space myths debunked. Remember, the universe is a fascinating place full of wonders and mysteries waiting to be discovered. Until next time, keep looking up.